Yeah, hello everyone. In today's video, we are going to discuss LTI system characterization using differential equation. So when we talk about the LTI system, there are three different parameters that we should know. These are the input, output and the impulse response. For this LTI system, let us suppose xt is the input, yt is the output and ht is the impulse response. It is called as a impulse response. Okay, in time domain. Now these three parameters xt, ht, yt can be related through a differential equation, linear constant coefficient differential equation, and it can be written as summation k equals to 0 to capital N a k dkyt over dtk is equals to summation k equals to 0 to m bk dk xt over dtk. This is a linear constant coefficient differential equation. Linear constant coefficient differential equation, right? In this ak and bk are the constant coefficient. Now when you take the Laplace transform of this equation and then solving, you will get the ratio of this and this in S domain can be written as ys upon xs is equals to summation k equals to 0 to m bk s to the power k summation k equals to 0 to n ak s to the power k, right? And you already know the ratio of this as we have discussed in Fourier transform. It was written as, in Fourier transform it was written as, and the term is called as a frequency response, right? In S domain it is hs and is called as system function, or we can call it as transfer function, right? So you should have to keep in mind that in time domain this ht is the impulse response, and when in S domain, when you represent it an S domain, it is h of s is system function, or we can call it as a transfer function also, right? So we can discuss the examples based on it. Consider the example based on it. In this example, you have to find the transfer function or the system function and the impulse response, means hs and ht you have to find of a causal LTI system, and the system is described by the differential equation given by d square yt over dt square plus 2 dyt over dt plus yt is equals to dxt over dt minus 2xt, right? Now how you can solve it? Take the Laplace transform of this equation. When you take the Laplace transform of this equation, it will be s square ys plus 2s ys plus ys is equal to s square ys minus 2xs. Okay, right? Take the ys common. It will be s square plus 2s plus 1 is equals to, take xs common, s minus 2. Now take the ratio of ys and xs. It will be ys upon xs is equal to s minus 2 upon s square plus 2s plus 1, and this can be written as hs, and it is also called as system function. Okay, now take this is the system function that you have to identify, right? Now you have to identify the impulse response of this function. When you identify the impulse response of this function, you have to take the partial fraction, right? When you take the partial fraction, how you can take the partial fraction? This can be written as s minus 2 upon s plus 1 whole square, right? So in partial fraction form, this can be written as hs upon a upon s plus 1 plus b upon s plus 1 whole square. Now use the partial fraction properties. Partial fraction properties to find the partial fraction. Okay. After finding the values of a and b, we can write it as hs is equals to 1 upon s plus 1 minus 3 upon s plus 1 whole square. 3 upon s plus 1 whole square. Now you should, to identify the inverse Laplace transform, you should know the transform pairs to write the transform of the given function. Okay. Now as you know that the transform of e to the power minus t ut is 1 upon s plus 1, and for t e to the power minus t ut has the Laplace transform 1 upon s plus 1 whole square. So ht can be written as e to the power minus t ut minus 3t e to the power minus t ut. So this is the impulse response that you have to identify in the given question. Okay. The next question is, in this question, the unit step response is st is equal to 2 e to the power minus t ut. Right. Now in this you have to determine system function hs and impulse response ht. How you can determine unit step response means, what is given? It is given that the input xt is ut, and for this input yt is 2 e to the power minus t ut. Okay. Now you have to find the hs and ht. Right. So find the Laplace transform of both xt and yt. Xs will be 1 upon s, and ys is equals to 2 upon s plus 1, right? Okay. Now write the relationship between xs, ys and hs. It is ys upon xs is equals to hs. So it can be written as 2 upon s plus 1 upon 1 upon s. Okay. So it will be 2s upon s plus 1. Right. Now it can be written as 2s plus 2 minus 2 upon s plus 1. And this can be written as 2s plus 1 upon s plus 1 minus 2 upon s plus 1. Right. cancel this. It will be 2 minus 2 upon s plus 1. Now this is your hs. For this you have to write ht. Now ht 1, 2, 1 is multiplied with 2 and the Laplace transform of delta t is 1. Okay, so you can write it as 2 delta t minus 2 e to the power minus t ut. This is your impulse response. These all are the questions based on the linear constant coefficient differential equation. Thank you so much.